Good afternoon, class. This is Jigar Pandya, and we are here for BDA class, 2:30 p.m. Can one of you confirm me? You can hear me? Can you hear me? Thank you. And how about, can you see the screen too? All right, so this is first lecture after first sessional, right? So, of course, we'll have to dive into legal theory. We'll have to connect points, right? Prior to exam and prior to reading week, we were actually talking about Hive, and the following Monday we supposed to had Hive lab, but then there was a reading week and the whole exam, and immediately we had to conduct two labs back to back. You remember on Sunday, one of the lab we conducted lab 7, which was related to Hive, HIVE, and then on Monday this week we conducted lab on big data cluster with respect to Oracle Cloud Infrastructure, right? We still have to go through topics from the book pertaining to Hive, HIVE, and then of course I'll walk you through the website, the hive.apache.org itself, because there have been changes. There are latest things up there other than textbook. I'm not certain how many of you are having a textbook, but then there is the latest edition also in the market, may be available on Flipkart, Snapdeal, or Amazon. You may find it. Otherwise, definitely the official documentation of each and every topics are more than enough, to get you in the depth. Okay, so let me quickly go through the book content, what we got. I'm now sharing the slide from uh, instructor's material shared by the book itself. Okay, so what you need to learn about Hive? Of course, you need to know what is Hive. Then you have to learn about architecture of Hive. Then you need to learn about data types supported by Hive, and finally, you would each and every tool will have its own data model. What I mean by data model, how does it store data, and what is the read process, what is the write process, all those things fall under the data model part. Uh, let's move on with Hive. So of course it's a query language, what we know, right? Because we have conducted labs also, right? And then there'll be DDL and DML, right? What you need to learn more about Hive as a data model part, it, at a high level, it has database, then tables, then partitions, and then buckets. I mean, this is the hierarchy you can think of. Okay. And of course, you will have aggregation supported, you will have group by supported. And we'll talk about something called SCRDE, SCRDE. We talked about it a bit. SCRDE stands for serialization and deserialization, right? So what is Hive? It's a data warehousing tool, right? It uses the query structure data built on top of Hadoop, right? People say Facebook created Hive to grow their ever-growing volumes of data, and then HDFS for storage, right? MapReduce for execution, and it stores metadata. This is important. It stores metadata in RDBMS, and which is also termed to be metastore. I repeat, Hive stores the metadata into RDBMS, and it is also termed to be metastore. And if you can answer, which is the default meta store picked by Hive when you install and get started. What was that RDBMS name of the software or name of the RDBMS? Yes, Ashish and Ria, Derby. Yes, DERBY, correct, Derby DB. That's what we know that is the meta store for Hive, right? You can definitely change that if you follow some configuration. You can do MySQL also if you may want. Anyways, uh, for storage it uses HDFS, and of course the execution is MapReduce. But then this MapReduce can also be from different engines. Okay, it's not like it can use only Yarn from your Apache Hadoop. It can also use something called TEZ and something called Spark. It can use it. You have to configure accordingly. Okay. Moreover, it's not that it will only use HDFS for actual data storage. It also supports something called external types of table, where you will have to, you will have choice to connect to remote storage, which might be, Amazon S3 or anything like those. Okay, so there is flexibility in the model, uh, right? Based on your requirement and purpose, you will be able to do that. So Hive features similar to SQL structured query language is actually HiveQL, known as. It's easy to code. It supports rich data types. Now, anything when we learn, we come to learn about its features. So this is one of the features. The stronger the data types, stronger the platform can be. And C, it supports structs, struct struct from your C language, right? So even in Hive, you can create structure. Now, know that in Oracle SQL, you might not have explored, creating structure, but in Hive, it is possible. You can create a structure. Okay, and of course, the notation is the same. You can use the dot notation to access members of structure. Okay. Then you can have list, you can have maps. Actually, there are more data types. We'll check. Okay, and it supports filters like group by, order by, closes, etc. Fine. So data types very quickly. Uh, it starts with databases, tables, partitions, and buckets. So this is again kind of rooms, like in your house you have rooms. In your room you have, let's say, wardrobe. In wardrobe you have, let's say, boxes. I mean, very much like this. Okay. So databases at the topmost levels, buckets at the lowermost levels, and buckets sometimes are also termed to be clusters. Okay. But then set of buckets constitute partition, set of partitions may constitute tables, and of course set of tables constitutes uh, databases, right? So all these things you have already heard. This is straightforward to follow, right? The architecture wise, this is a diagram once, upon a time, I would say, right? But right, uh, so you have Hive, right? That is the command line interface. When you just say Hive, it gets you started with Hive command line CLI. But there is something called Hive web interface also, and there is something called Hive server. In the market right now is Hive server 2 also, which is actually connected via Crypt. Okay. Uh, Fine. So there are many more things, but this is the meta store what we talk about. This is the place for Derby, which is you can think like it is storing your metadata. Okay, and of course you have driver, which will have query, compiler, and executor. So query compiler means when you give query, it will have to first check the syntax, etc. That's the query compiler, and executor, which will execute your query. That's in general known as a driver. Okay, so bottom line, it uses MapReduce and Hadoop distributed file system, but there can be various different components on the bottom side. Okay, there can be more components on the bottom side. So this is one of the layer diagram, possible layer diagram with Hadoop architecture. Now, if I would want to switch to the current Hadoop Hive, of course, you would go to Apache, hive.apache.org. Okay, that's the uh, website what you are right now seeing, hive.apache.org. Right? You may download and there's something called Confluence, uh, which is a wiki by Apache. I repeat, Confluence, which is a wiki software or wiki software from Apache, and all of the Hive documentations are dumped or created onto Apache Confluence Hive page, which is what this one is. If you may go to cvk.apache.org/confluence/display/hive, that's what this URL is. That's what you may see here. Confluence, that's the Wikipedia like Apache product, and Apache dumps all the documentation on its own wiki called Confluence. Okay. So specifically for this Apache Hive, you should refer to this Hive wiki, which is on Confluence. Okay. Now, of course, you could read more the latest one here, right? If you see here, it let you store files directly into HDFS, or it also let you store file in HBase, right? Then the query execution, it can do via MapReduce, which what we know, right? Hadoop MapReduce. But it also let you do query execution via Apache Tez, T-E-Z. Now this is one more, MapReduce engine in a way by Apache itself. And there is, in one line, if I were to say, when you actually run subqueries, right? If you remember in lab 7, we saw Apache Hive subquery also, and we saw that there will be internal MapReduce job, which will then provide output to the external MapReduce job, if you remember that. So there actually the data is written to file HDFS in the intermediate stage when you move from MapReduce job 1 to MapReduce job 2. But such things are avoided in Apache Tez. So I repeat, Apache Tez is more performance oriented than the original Apache MapReduce, particularly when you run join like subqueries and when you try to join, right? Because Apache Tez doesn't write the intermediate data into HDFS. It tries to write it into the memory itself. Okay? It has its own mechanism, data model, of course. But then Apache Tez, this is one reason why it is faster than MapReduce, which is it doesn't store intermediate data into HDFS. Anyways, so be aware that query execution engine can be selected, chosen, right? The other day, if you remember, I started only HDFS on my computer, and I started Hive. You remember it was not going through, and I asked you like, shall we find out whether Hive has a separate or bundled query execution engine or not? So know that it doesn't have bundled query execution engine, but it default relies on Hadoop MapReduce, and you can also configure it to work with Spark or Tez, right? So fine. There are more things to read from this. We'll talk about file formats. We'll talk about serialization and deserialization, right? And there is something called H catalog. It's a table and storage management layer for Hadoop that enables users with different data processing tools. Like you can actually have stack of tools like HDFS, then Hive, then Peak, etc. Okay, so this is more like interfacing with other tools, H catalog, like you do so. Okay. Anyways, we are not going in depth of H catalog and web HCat. No, we are not going in depth of them. We'll stick with the core Hive part of it. Okay, and fine. So as mentioned, Thrift is one of the Hive client, I repeat, thread is one of the Hive client. Okay, um, fine. But then what I found from somewhere maybe on tutorial also, I found this design page which says design, okay, Hive design, and I found this Hive architecture link here on this URL on the wiki itself, and the architecture what we were describing from the book, at least you can also see a little bit more detail about it. So this is, for example, the Hive part on the left hand side. On the right hand side, let's say you have the Hadoop part, and you know Hadoop will have data nodes, name nodes, and job tracker and task tracker. So of course this diagram, though is there on the wiki, it is an older one because in old MapReduce 1 it used to be job tracker and task tracker. We know MapReduce 2 has uh, resource manager and node manager, right? Anyways, so this left hand side is more important to understand. So when you will via any of the Hive client, you will provide a query, right? The query will actually go to the compiler to get the plan. The compiler will, fetch the metadata from the metastore, validate it. The metastore will send the metadata. Compiler will do the job of compilation, and then that particular plan, it will send it to the driver program. Driver program then will give the plan to the execution engine. Know that in this diagram, the execution engine is the Hadoop MapReduce itself, but then it can be something else also, right? So imagine the execution started and execution completed, right? Fetch results, right? Execute job done 6.2, job completed, for example, right? And once the job completes, I mean the result is ready. Of course, there will be metadata operations for DDLs, like data definition language, right? That's both way. So it's not only reads from metastore, but it also writes into metastore, right, as needed, as and when needed. And see this results, right? It is also both ways. I mean, there may be intermediate things also. That's why it is shown both ways, right? Basically, Hadoop, is the backend, but Hive is the query engine. I mean, the database part of it. I mean, database management system kind of thing you can talk about. Anyways, so going to the book diagram of the Hive architecture. This is what the book has to say, Hive architecture, right? And I mean, if you may want detail, it is there from the Hive wiki also, right? Okay. Let me just confirm that you are able to hear me. So far, so good. It's raining here, and it's 2:49. I hope you are with me. Can one of you confirm that we are connected? Thank you, Dave. Okay. All right. So moving forward from the architecture, let's move to the next data types, Hive data types, right? Again, a lot of common stuff you may want to talk about, like tiny int, small int, etc. I will not go in depth of all these things because my job is to give you, the current, the whole. You can definitely explore on your own, right? There's something called binary as one of the data type, which can be very similar to your blob, right? And let's see what next we have got. Yeah, this is what the structure as a data type, what we are talking about, right? Map we already know is very much like a hash map, right? And then array also we are aware. So data types wise structure is one more something new in this Hive, being a SQL supported software. Fine. Let's talk about file format now. So basically, when you load data into Hive, they are loaded into either of HDMS or S3 on those lines, right? Now, which different types of files you can have in your HDFS or S3? So it can be simple, plain, regular, text file. But then, if you remember, Hadoop cannot perform well if your text files are very smaller size. Let's say I have million files, but they are very small, like each maybe 10 KB, for example. So though I have so many number of files, but the file themselves are very small, what will happen? Will Hive perform? I'm sorry. Will Hadoop perform at its best? Can someone focus on this particular question? It is actually belonging to sessional 1 in a way. But let's just take up, because we are taking up these few more file types now. I repeat the question. Let's say I have 1 million data files in my HDFS, but their sizes overall are each maybe on average of 1 KB or so, or 10 KB or so, let's say. So, is it a good scenario? I mean, should I have my files as raw files only, which are of each of 10 KB? Can I improvise something, or what is wrong? I mean, what is gonna be trouble if I have 1 million files, each of only 10 KB, like smaller in size? What is the problem? Fine. So Vivek says metadata for each file will be more than the actual data stored. Correct. So you all have heard about this, madam repeated so many times, right? The metadata, the name node, which is the master, which actually takes care of metadata, and what is that FS image and what is the other name? You have learned about those topics, right? FS image and what was the other name? But you know that metadata, it stores in the memory only. Know that name node, metadata, I mean, out of those two, one, the FS image and the other, is always kept in the memory, right? And then it is synchronized by the secondary name node, right? So know that here, if you would have small files, though they may be, so many numbers, but then to maintain their each and every small files metadata, I mean the file name, location, owner, etc., that itself will, fill the the memory, right? It itself will, utilize a lot of primary memory, right? And hence, Hadoop will not be able to perform well for sure. Know that Hadoop is optimized to perform with large files. This is one of the reason that it had this design of having metadata, FS image, etc. And there is secondary name node which takes care of persisting information, etc. Right? With that design, they kept in mind that our files will be always larger than the block sizes even. Let's say 128 KB is the default block size, but they assume each file will be 1000 K. I'm sorry, 128 MB is the default block size. They assume that each and every file will be 1000 MB plus, for example. Okay, that's what they aim. Why this infrastructure is in place. So ideally, what I'm telling, if you might store data in text files, and if the text files are very smaller in size, Hadoop is not going to perform well. So what are your options? So your options, the next option is something called sequential file. Now know that this is nothing but a file format, okay? You will have to actually dump the data into sequential file, so-called, and actually all those small files can participate or can be part of a single sequence file. And when you provide this file, data file to Hadoop, you are not giving all those small 100 or millions. At least out of million, you will definitely distribute. But then, let's say there are 100 small files, each of 10 KB. You may keep it into one sequential file. So that way the metadata will be less. Okay. So that's the sequential file purpose. It is already been implemented. We will have to use its API, right? And we'll see more about sequential file. I have another document also to support this. But for now, learn that sequential file is to help you combine so many smaller data files into one, and because of which the Hadoop will be able to perform better. The reason being, it will not have to maintain the metadata of each and every smaller files. Okay, and the next type of file Hive will be able to deal with something called RC file, the full form record columnar file, right? Now, as the name columnar suggests you, that RC file stores the data in a column-oriented manner, and not only single column. We already have learned about something called column families, right? So basically, you can think like one RC file for one column family, which ensures that the aggregation operation is not an expensive operation. I mean, the other way around, the same statement, which ensures that the aggregation operation will be a will be an inexpensive operation. I mean, will be faster operation. Okay, provided you store data into the column-oriented manner. Anyways, that's what your book has to say about 3 types of files, right? And then we'll follow with query language. I will not go in query language right now. It's nothing but CRUD operations. But let me talk about more from the Hive wiki itself. So we talked about the architecture, right? Let's talk about these file types only for now. Let me see, where is it? Okay, so just maybe a little bit of repeat. We know Hive architecture. It has UI, driver, compiler, metastore, and execution engine, right? We then will we want to talk about Hive data model, right? So the Hive is organized into tables, right? Partitions, buckets, right? Now, what is the difference between partition and bucket? Know that buckets are within partitions, okay? And you can definitely read this information, right? Data in each partition may in turn be divided into buckets based on the hash of a column in the table, right? Each bucket is stored as a file in the partition directory, right? And one more thing, when we talk about this, know that all the data used by Hive, they are actually there in directories, and they will have files also. Okay, so for example, for a given partition, there will be a directory, and for a given partition, you have 5 buckets created. Then there will be 5 subdirectories. See, bucketing allows the system to efficiently evaluate queries that depend on a sample of data. So basically, bucketing is very much like when you take the example what ma'am used to take with your car models and all. So bucketing is like you go in depth of car model to car type and all. Okay. So apart from immunity column types, it also supports arrays and maps. This is all mentioned here, right? So for your exam or for your preparation, I will not be able to share the PDF or anything else, but this is what you should be looking at. I'll be sharing these links with you, or you should be also able to locate these links on your own. Okay. The reason being is all documented here. I don't want to prepare, a separate replica of the same information. Fine. So we talked about metastore, right? There is more to talk about, but I just wanted to move on to the fine. I wanted to move on to the file types. Okay, file types. Let me just grab it. 1 minute, please. So for that, you'll have to go to the Any questions so far? Anybody? File formats and compression. Okay, and you see that let's talk about this now. File formats and compressions. Okay, these are actually the latest one. Okay, what we see or what might have been described in the book, maybe as per that year of the book written, right? But the latest you will definitely get it from the official documentation. Okay. That's when I have to move on to the official documentation most of the time. Okay. Any questions so far? We have talked about Hive architecture, data model, right? We talked about data types supported. We talked about file types as per the theory book. But then we are now moving on to learning more about file types. We understood the purpose of SQL shell file, right? Any questions so far? Anybody? Now, of course, you will have a question how to create a sequential file and likewise, right? So that's the practical part. We'll see whenever we can do that. But then theoretically, you have to understand that sequential file is a collection of smaller files. Okay. Uh, okay. So we were moving on to the file formats and compression, right? So let me go there and see what we got. But then the list is given here as for the latest RC file, as we know the name at least, record columnar file. And see, there's something known to us. Do we know this particular file? Or do we know this word? AVRO. What is AVRO? Anybody explored? Anybody did any hands-on, any simple stuff with it? What is AVRO? 81 students are there. How many of you were present on Sunday? We talked about AVRO. There's the spelling AVRO. Hmm? What is that? Did we pick a data file with a format AVRO? It was ready-made available, but know that you can write, softwares which can generate AVRO file also, and of course you have to use the AVRO APIs, right, appropriately. The way we do C file handling, you can also do, Avro type of file handling. So that will be generator, data generator, right? But then provided the data file given AVRO format, uh, three of you, I believe, could install Avro tools, and then one for Mac, one for Linux, and one for Windows. And you could at least see the schema of AVRO file, that particular data file, and it was the movie schema, if you remember, right? Movie schema. And so, what is the basic uh, format Avro uses for communication? And that is, which format Avro uses for communication is nothing but JSON. Okay, it's nothing but JSON. So now you might think of like format within format. I mean, how does it make sense and all, right? So see, Avro is not just simple file format. It is more than that. So you definitely have to go to avro.apache.org and learn about it. But let's just see what is here in Hive, right? Related to that. Uh, so RC file Avro. Now, what is ORC? It is actually the current version of RC. Okay, so that's what ORC is called. There is something called Parquet, and these are comparison like LZO. Okay, there is something called Snappy, SNAPPY, which is also famous for comparison. Anyway, so there are a lot of tools actually, honestly, and not all are possible to explore. I mean, not everything can be explored, but we'll definitely see some of them, however we know, right? At least your book described one simple data set. Given the given 5 rows, each having 3 columns. Given that data set, how RC file will store it, and that has to do very similar to your row measure and column measure. Okay, so that's a very simple naive example. I mean, I don't want to even talk about, right, row measure and column measure, the array, if you take, right, how the array will be stored into physical if it is row measure, versus how the array will be stored into physical if it is column measure. So there is an example given in your book. So that I will leave as self study. But it's nothing but how the data is stored into column measure. That's exactly that. Okay. Uh, So see again here it talks about text file and sequence file, right? And then they have given link for other types of supported formats. And let's just talk about RC file. Okay, what is RC file? It's a record columnar file, right? It stores table data in a flat file consisting of binary key value pairs. Right? It first partitions rows horizontally into row splits, and then it vertically partitions each row split in a columnar way. So this is what I was talking about. It's like very much like column-oriented storage. It is very much like column-oriented storage, right? The only thing new will be the partition here. Okay. So first the data. So partitions are based on row themselves. Okay. So let's say I have 10 rows and I have kind of two partition created uh, based on, let's say, city, right? And out of 10 rows, there are two distinct cities. So one partition will have 3 rows and another partition will have 7 rows. Now within the partition, those 3 rows will be stored in a columnar way. Again, within the second partition, another 7 rows that belongs to city B, for example, it will be again stored in a columnar way. That's what this line of statement is talking about. Okay, so partition is based on the row, but once the rows are kind of dumped into partition, I mean ready to be dumped into partition, there within the partition, it actually stores in a columnar way. That means it stores column by column. Okay. RC file stores the metadata of a row split as the key part of a record, and all of the data of a row split as the value part. I mean, now this is more, architecture-wise, right? If you want to go in depth, you can definitely read this. But RC file is just a type, what you may be able to use it in your Hive. So far in our Hive, we have used Avro file. We have not used RC file, right? We have used Avro file. So I won't be able to, have you practiced all the type of files, but at least you have done the Avro file uses. That's when you have to select the input type and output type appropriate classes, if you remember from the lab. When we were loading the Avro file into table in the Hive, there were appropriate input-output format classes, the jar names, I mean the fully qualified class name, if you remember. Anyway, so this is actually the RC file is open to other tools also. It's not like RC file is just with Hive. No, it's not. Okay, and the same is true with Avro and others. They are all formats which can be utilized by various tools. Right? Avro files we have talked about. We still will touch it. Let's see. Let us take us. So working with Avro from Hive, I mean, we already did this bit, right, in the lab part, right? But the best way to understand what is Avro is avro.apache.org. Okay, this is the internal documentation of Hive itself. But if you want to learn what is Avro in itself, you better go to avro.apache.org. So once the file types will be finished, there will be something called serialization and deserialization. Now, can someone write a brief definition of serialization and deserialization in the chat window, please? Okay. So maybe you have just used serialization in Java, but you might know what is behind the scene, right? Uh, so for that, you might have to refer some sites. Maybe I'll share the links with you. Uh, okay, let me ask you this question: when you do serialization, is storing or retrieving? So serialization is storing, right? Correct. And deserialization is retrieving, right? Okay, fine. Now let's talk about serialization first. Uh, what exactly are we storing? It is primarily have to be some objects, okay? So you store some object. Now, when you store some object, yes, Devan, correct. So you store some objects, right? Now, if you remember in first semester C language, you might have learned file IO handling. There also, when you would use app printf or app scanf, you would be writing or reading from file in a text manner. And when you will use maybe f read or f write kind of functions, you were actually doing binary reading and writing, if you remember that, right? So there also, imagine integer, long, float, etc. Are kind of data types. Let's just say object, for example. You are writing them into binary, right? You are dumping them into file. If you remember, let's say I have integer int and x equal to 1, 2, 3, 4, 5, 6, for example. Imagine the capacity is appropriately. Let's say 4 byte size, and I'm showing 1, 2, 3, 4, 5, 6. When I write this 1, 2, 3, 4, 5, 6 using f write, and if I write using maybe f put or f printf, what is the difference? Let me repeat the question. I have an integer. Let's say capacity is 4 bytes. I have stored 1, 2, 3, 4, 5, 6. Uh, I have two choices. One is to write text file, another is to write binary file. What is the difference? Anybody is aware that particular logic, simple logic? What will be the size of the file, or at least how many bytes will be written in both the cases? In the text cases, though it is integer, you are writing 1, 2, 3, 4, 5, 6, that means 6 digits. Each of them will be converted as corresponding ASCII, and hence minimum 6 bytes will be written in the text case. In the binary case, what will happen? Whatever the memory print of that 4 bytes, they 4 bytes will be stored into the file. How many of you were aware of this? Did you get the difference between writing a text file or writing a binary file? That's what happens behind the scene. I hope you guys know that. Uh, uh, okay, I'm not certain how many of you knew that, but hopefully you at least know now. Did it make sense what I just said? In integer x, you have 1, 2, 3, 4, 5, 6. When you write to a text file, that integer data gets converted to literally text digits. So that will be 6 digits, 6 bytes minimum, getting written. And if you write in a binary, the 4 bytes, what was the capacity of your integer, which actually holds zeros and ones sequence, but those 4 bytes will be written as is from primary memory to the file, right? That's what binary is. So now talking about serialization here, we know it will write objects, right? So basically, very much like those 4 bytes, it is writing right away in the file. It's very much like that. Imagine your object is of 40 bytes, then it will write those 40 bytes from your memory directly to the file. Is that enough? I mean, is that enough, or there's few more things to be done? About serialization we are talking. See, this all things actually, date back to your Java or OP or, further topics. But I got to take this up because I felt like many of us are not clear with many more things. Okay. Any guess? Will it write only 40 bytes? Let's say object is of 40 bytes. So will it just write 40 bytes, or there will be more things also? If you want to explore this, you'll have to learn something called serialization protocol. It's altogether a protocol, okay? And various languages have implemented it, like Java and all. So serialization is a protocol. What actually it writes not only those 40 bytes of data, but it also needs to write some header or metadata. what that header will have to contain and why. See, what is the purpose? When you store object, the purpose is you also retrieve back the object. Okay, I mean, from object you are transferring into bytes format, whether it is to be written to a file or it is to be transferred over the network. There can be various purposes. Okay, it's not only serialization doesn't just mean writing to a file. Nowadays it has one more purpose, which is transferring over network. Okay, so in both cases, it has its own importance, and that is the same purpose. Okay. So whether it is 40 bytes to be written to a file or 40 bytes to be transferred over network, right? It also needs the other side, the other end of the network who is receiving those 40 bytes. He should be able to create the object back. Now, what more information does he need? The other side. Of course, the other side program needs more information, right? Not only these 40 bytes will help him. It also needs to know which type of object is it. I mean, this object is of which class, right? Then that class contains what all data members, right? And if there are any parent classes, it will need to know all those information and know that serialization is about all these things. There are tutorials available in the market. You may go through them if you want to learn about it. But know that serialization has to do with not only storing the data in the form of binary, but also providing the metadata so that on the other side you will be able to create the object back from the sequence of bytes or series of bytes. Fine. So serialization and deserialization, as we talked about, right? We at least understand what is serialization and deserialization, right? And it's a protocol in all together. Okay. How uses the SerDes interface. So this is the implementation part. For example, Java will have interface for serialization, right? So that way, Hive has this SerDes interface for I/O. You can actually use it in your APIs in your program, right? But we know what is the purpose of serialization and deserialization now, little more than before, right? So the interface handles both serialization and deserialization, and also interpreting the results of serialization as individual fields for processing. So basically, it not only now in the case of SQL, because Hive is a kind of SQL, it will not only store object and parent class information. Here it will have to store maybe the bucket information or partition information or table information and database information likewise like for. So based on the purpose of serialization, deserialization, the metadata will vary. Okay. In the case of when you write plain objects in Java, you would have class names, maybe fully qualified class names, etc. In the case of Hive, maybe it will store other details like partition types, partition name. The partition names or table names, maybe the database name, etc. Anyway, so serialization, deserialization supported. Okay, and we are not going into APIs part, but then be aware this is there is built-in serialization, deserialization, but you can also create custom of your own. Fine. So there are more detailing about it. Okay. And in serialization and deserialization, how you actually suppose let you by default serialization, deserialize these all things like arrow, ORC, regular expression, part weight, CSV, right, JSON, etc. Okay, so I'll go to the book content again. I have switched the window. Okay, hopefully you are able to. We are all connected here. And what is the time now? 10 minutes to go. Fine. Some of you please say that we are connected. Are we connected? Thank you, Jamin. Fine. So, other than query language, let's talk. So, let me just go through this slides very quickly. Okay. Actually, I had other plan, but let's not go with query language right now. Let's talk about the architectures only. Okay. Some group of students wanted to have installation steps also. So just find out from wiki how there are installation steps, right? And I mean they are really straightforward. This is a maybe latest version, but you extract the zip file, right? Then maybe you set few environment variables, right? Maybe you add into your path variable, right? And then don't go with installing from source code. Okay, we are not kind of building the source code. Otherwise, it will be more. You will have to go to Git, download the source code, build it, etc. So that's not what we are after. That's what it is, right? Not Git, but SVN. I hope you know what is SVN. Is subversion. Okay, this plan master architecture. Subversion is a source repository tool, right? But it is client server architecture, while Git is distributed architecture. Git is a distributed architecture. At least Hive developers, they are using SVN. I have extensively used SVN in the past. Anyways, but that's not what you want to go about. Okay, you just install Hive. The only thing what you need to do is the meta store configure. If you may want to change it to MySQL also. Otherwise, you just have to create a data directory. Hive location. Why is it not mentioned here? I'll have to check it. Okay. Uh, See, it uses the Hive.b in server mode. Okay. Anyways, so fine. We'll revisit this part if needed. We'll revisit this part. Okay. Actually, this is little latest also, where you have further components added like edge catalog and webkit. Okay. Let me take up this small topic here, which is called external versus managed type of table with respect to Hive. See, you can have two types of tables in Hive. I mean, when you create the table, you can specify this external keyword, and that way it will create a type of external table. I repeat, there are two types of tables Hive is supporting, and they are termed to be internal and external. But internal is actually named here as managed. Okay, the internal tables are actually named as managed tables. Now, what is the difference? Uh, okay, so let me see if I have a query here. Okay, I don't have a query here. I'll have to go to other link also. So, understand theoretically, so the fundamental difference is Hive assumes that it owns the data for managed tables. I mean, those which are termed to be managed tables, or you may say internal tables, know that they are your own, I mean, users tables only, but you are telling it as managed table, and all of its data, Hive assumes that it is the owner of that data. So nobody will come and corrupt it. I mean, nobody will come and change it. That's what Hive assumes. Okay. So let's say you have some data which you want to be used by multiple tools. Then those data you will not, utilize. When you would want to create a table on top of that data, you would not create an internal table. You will create an external table. So that's actually the difference. I repeat, let's say you have data files and which supposed to be used by multiple tools, not only by Hive but others also. For example, in that case, you would choose to create a table in Hive called external table. Okay. Otherwise, what will happen? Maybe other tools, if by some chance, if they are changing it, Hive may not be able to follow it. Okay. So that means that the data, its properties and data layout will and can only be changed via Hive command. So if it is managed table or internal table, Hive assumes that it has all the power, it owns it, and those data, it will be only changed by Hive. And this is for your internal or managed tables. So I believe you understand what is internal or managed table. That is very much like Hive owns it, and Hive assumes that nobody else will, change anything or corrupt anything. Versus the external types of table, what you create is Hive assumes that okay, there can be other tools which will be using it. So Hive will not be completely relying on schema files. It might have its own internal schema, but the table will be still considered to be external. So that's what a type of table called internal and external. Honestly, you don't want to care about this if you are just using Hive, okay? But then if you are using multiple tools, at that time, you will have to think of this, okay? So read through this. The external tables, Hive assumes that it does not manage the data. For the external tables, Hive assumes that it does not manage the data. Data might be managed, or external tables can be identified using so and so command name. Okay, and actually I saw somewhere it also talks about external table can connect to external managed tables can also connect to Amazon S3 or otherwise. Okay, it is about it. The internal table locations will be always the warehouse. If you remember, we created a particular folder in HDFS called Hive Warehouse. So when you will create internal tables, they all will be having directories in this particular location. Even when you will have files outside and you create internal table on top of them, those files will be moved in this warehouse folder. Versus the external table where wherever the file is, they will stay there it is. For example, the data files are in Amazon S3 and you are actually creating an external table in your Hive. The files in Amazon S3 will stay there itself, and Hive will be actually utilizing it for whatever data processing purpose. So know the difference between internal managed versus external. So don't use the word internal, please utilize the word managed. Okay, because this both managed as well as external, they both are tables of users only. See, if you remember, we talked about Oracle. We say that there will be internal tables of Oracles, right? Which is like system tables. So know that this Hive managed tables are not system tables. I repeat, last is been 3:30 now. I repeat, the managed tables in Hive are not system tables. No. Okay. Both of these, managed as well as external, both of these are user tables only. Okay, for the data sets of users. Okay, but then their purpose and their handling is little different. So we just talked about one topic called manage versus external table, and that's actually touched in one of the slides in your book also. Here it is. Hive provides two kind of tables. One is managed and another is external. So I would expect that you refer these differences and you experience this difference from the official website. Fine. So it's and how do you create table? You just say create table, and no, you have not provided external keyword here. That's why it will create only by default managed tables. But then when you will actually say external here, the keyword external, then it will actually create an external table, external type of table. Okay, and the difference as we understood. Fine. So we'll stop here. Okay. All right. Thank you very much for your time. I'll disconnect now.
Okay, so good afternoon all. In last laboratory, that is lab 6, we have discussed this logistic regression, right? We have discussed two versions. One is we have developed this sketch, and another one is using the TensorFlow. And we are supposed to develop the another version, the third version, using the PyTorch library, right? So today, we'll, as we have discussed in the last lab also, today we'll see uh, NLP application using this logistic regression, and specifically, we are interested to see the classification of tweets using this logistic regression. Right. So quickly download the file, which is already shared in the Google Drive folder. And if you observe the file, some code is given to you, and the other code you are supposed to complete. So we all together parallelly complete that code, and make sure that this time I am not going to provide this file. So the better you should write the code parallelly. Whenever I am writing the code, you should write the same thing. And so just quickly download it, open it in the Colab or Jupyter Notebook, and then we'll begin the discussion. Maybe around 3:35 or 3:40. Right. So till that, just download and be ready with the setup, and just go through the file, and then we will start the discussion. Okay, so I hope you guys have downloaded the file and you are ready with the setup. And please execute first true cell, where in the first cell we have some import, where we are importing the NLTK as well as the Twitter data set from the NLTK, as well as we are importing the pandas. While in the second cell, we are downloading the Twitter sample as well as we are downloading the stop pod. And once again, that both the lists are from the NLTK library itself. Right. So just complete the first and the second step. Right. Just execute the two steps. Next, in the third step, we are importing a regular expression, that is RE, string, a popular library NumPy, and pointer stream as well as the tokenizer, right? And over here, as a tokenizer, we are going to use NLTK's tokenizer, and from that specifically, we are going to use a tweet tokenizer. One interesting thing related to this tweet tokenizer. So before moving towards the next cell or before starting the actual discussion, I want to spend some time on this tweet tokenizer. So just execute the first three lines or first three cells, and then we'll begin with the discussion of this tweet tokenizer, and then later we'll discuss the laboratory task, that is logistic regression. And as you might have seen in the shared Excel, the deadline for the previous lab as well as this particular lab is mentioned over there. So make sure that you submit your assignment before the deadline as usual. So parallelly, whenever you are performing the task, can anyone just write something in a comment related to steam operation? That is, in one of the laboratory we have discussed this portal steamer, and if you can recall the steam operation that we have discussed, which is one of the pre-processing tasks, or you can say one of the very important pre-processing tasks, which frequently people are doing with the NLP application. Though there is no role of this particular task in the image-based or the video-based application, but whenever there is a text, you probably have to use this steam operation, right? So can you just can anyone recall that steam operation? Right, correct. So Krinish and Vivek has given some examples. And so basically, and the usage, why we are using this steam operation. And I hope in one of the lab, if you can recall that lab, at the time we have discussed this portal steam algorithm. Right? And based on that algorithm, the steaming is performed. Right, and if you can recall, steaming and lemmatization, two words were there, and we have also observed what was the actual difference or exact difference between that steaming as well as the lemmatization operation, right? So the advantage of this steam operation, what's an advantage? Can you recall that? Steam over lemmatization will have the same advantage for our application. Exactly, it will reduce the size of your vocabulary, right? And so that whenever you apply the tokenization, or let's say whatever is the size of your original vocabulary, it will be reduced to, you can say, half or maybe more than that. And so the advantage of that is you need to use less number of token, and as you have a less number of token, the performance of model will be a bit faster, right? During the training as well as during the testing time. And so I hope you guys are ready now. So let's begin, and let me just share my screen once again. So before starting the original task, let's just spend some time with this tweet tokenizer, which is from the NLTK tokenizer. Actually, I have written the code. So let me just copy this particular code. why we are preferring this tokenizer compared to the other. The one good advantage that I found over here is this strip handler, strip handle, as well as the reduced length. These two are very interesting. Right now it's enabled, so let me just disable that thing. So we have, if you just check the first line, we have initialized the tweet tokenizer. Then using that tokenizer, we are tokenizing our string, and let's say that string or the input is hi friends. Right, and let's observe what will be the output. Right, and as we have two words, so it is just going to tokenize that word, where the first is the hi and the other one is a friend. Right? But the parameter of the parameter that we have removed from this. So let's say if I just reintroduce that reduce length and let me make it true, the by default value is false. If I just write reduce length and true, what's the output difference? So if you just enable this reduce length, then have you observed what exactly the output difference compared to the previous one and the current output? Right. So as the name suggests, it is going to reduce the length of your particular word, right? And remember that it's not going to check any vocabulary, it is not going to check any spelling of particular word. And this feature is there with the tweet tokenizer, because whenever we are dealing with the tweet, or let's say the WhatsApp or any other social media application or the platform, at that time frequently we are using this kind of word, right? Let's say the original word is just a hi, but we are many times we are using that hi, right? And so on. So this reduced length will help you to reduce the whatever, let's say if you have a repeated character, it will reduce it towards the 3 characters, right? Advantage. Can you think of any advantage of this particular thing? If I do not reduce the length, then what should be the behavior? Is there any change in the performance? Once again, less computation due to the less number of tokens. Because from the machine's perspective, if you just write hi, if you write I 10 times, or if you write I 100 times, that all three are the different words, right? So for all three, it will generate different tokens. So this reduced length will help you to reduce more than 3. If you have a similar character more than thrice, it will just reduce it to 3. And so it will help you to reduce once again your vocabulary size, right? So these are once again, you can say, one of the one another pre-processing task that you need to apply if you have this kind of data, or specifically social media data, right? And I hope if you have gone through the Twitter, there is a handle which generally start with the @ right? Which you can say your username. Handle is generally your username, or you can say your unique identification in Twitter. So if you want to deal with that handle, or let's say if you want to remove that handle, then you can use this strip handle, right? And you can enable that strip handle. Okay, so let me just give one example. So if you observe the current scenario, it is just going to reduce the length in the case of hi as well as in the case of friends. But if you observe this handle, that which generally start with the @ this is a term which is associated with the Twitter, right? So if you might not aware about this handle, so simply consider the handle means username, the unique identification of a particular account. in the Twitter, and it generally start with the @ fine. So now if I enable that, and if you observe the output, it is just going to reduce, or it is just going to remove that handle, right, or the username, because there is no role of the username whenever we are considering the sentiment analysis with respect to Twitter, right? And this first argument, that is preserve case, is just indicates that whether you want the whether you want to preserve the case, or you want to convert all your data into the smaller case, right? So these three are very interesting or very helpful input for this tweet tokenizer, which is actually a part of this NLTK. And so with this introduction, let's just begin with our original task. I'm going to delete this particular cell. Okay. So the first task, that is pre-processing. For whichever tweets that we have, we need to first pre-process that tweet. We need to generate the tokens, and then later we can submit it towards the model, that is the logistic regression model, and the model will predict the output, right? So we are going to perform some pre-processing task and input. This function process tweet will have a single tweet as an input. So for full data set, we'll call this particular process tweet in a loop, right? So at a time, this particular process tweet will have a single tweet. This function will take a single tweet as an input, and it will generate, you can say, the word list or the tokens which are in that particular tweet after performing some filtration. Fine. So now if you check the first line, we are initializing the porter streamer. We are considering the stop word list, which are the stop words of English. Right? We are performing some regular we are performing some RE expressions, right? Basically, we are removing some unnecessary tweets as well as unnecessary word from the data, right? Also, whenever we have the hashtag, we are just removing the hashtag. Whichever word associated with the hashtag, we'll keep it as it is, but we'll just remove that hashtag sign. Fine. So just go through this regular expression. Next, we are initializing this tokenizer, that is tweet tokenizer, right? We have just introduced this tweet tokenizer, and we know what exactly the use of this tweet tokenizer. And to that tokenizer, we are passing the tweet. And in this tweet tokens, we'll have tokens for particular tweet. But remember that this token are after applying all RE operation that we have just mentioned. Fine. So now you have words, or you can say now you have tokens from a given input tweet. Next, from this token, we want to perform, we are supposed to perform this 4 operation on these tokens. The first is we want to remove the stop words. Next, we want to remove the punctuation mark. That is, you can use the punctuation which is present in the string. Then we want to perform the stemming. And after performing all 3 steps on all the words, we'll add it into a list. And the list name is tweets clean. Fine. So I'm giving you some time. Try this 4 operation. So if you observe, we just have the for loop where we are considering all the tokens one by one, and at a time inside for a particular iteration, you just have one word inside in this variable word, right? So on the word, on the variable word, apply all for operation, and complete the code of this particular cell. Meanwhile, you can post your any if you have any question or doubt, you can just post it in the chat. Done. Right. So probably your code might be like this. If the particular word that we have right now in the current iteration, if it is not in the stop word list, right? We just have generated the stop word list. If you just check the same cell, the stop words underscore English contains all the stop words which are present in the English, right? And as a part of this NLTK, right? Rather than present in English, we can say as a part of NLTK, English stop word list, right? If the word is not in this list, as well as it is not a punctuation mark, right? You can just access all the punctuation from the string dot punctuation, right? And you can see which punctuation are covered over here, right? If you want to modify the list, you can modify always, right? And if you can recall, in one of the laboratory, we have modified this stop word list, right? We have added our own stop words and we have removed some unnecessary stop word from this, right? So that is application specific. You can customize that thing, punctuation as well as the stop word, right? But right now we are just keeping it as it is. We are considering all the stop word from the NLTK as well as we are considering all the punctuation from the string. Next, once you have that result, if the word is not a stop word as well as it is not the punctuation mark, that means it's an appropriate word. You should consider that particular word for the further processing. So one way is I can directly append that particular word to my final output. You can say it, I can consider it as a token. But rather than doing that, what we are doing, we are just applying that porters stream operation, and we are finding the stem word of that particular word, right? Or you can say the root word of that particular word, and we are adding that root word to our final result. Right. The question that Mayank is asking is, shouldn't we check that whether that particular word is already present in this particular tweets underscore clean? Anyone wants to answer this? Priyal say no, Muktan say order matters. Right. So Darshan and Mayank said that we should replace that particular list with the set, right? If the order is really matter, right? But remember that right now this processing we are not applying all in the full data set. We are applying this particular processing on a single tweet, right? So there is a very less chance that the particular word might get repeated, right? But let's say if it is there, then you should check. But I guess whenever you consider the Twitter data set, there is very less chance that the particular word is already present, and then you are retrying that thing, right? Anyhow, further, whenever we apply the further processing, we are not directly passing this particular data to our model. We are just extracting the important words from the tweet, right? But lateral, our model feature are not just words, right? So I hope at that time it might be clear what exactly that model features are. Right, so no matter whether that particular why we haven't removed that particular word, and the reason, I guess one of you have mentioned that, yes, Priyal, sometime we need to find frequency of a word, right? So reason is in this particular statement, right? So lateral, once we see the feature, our feature will be based on the frequency of a particular word, how many time it will be a part of positive sentiment and how many time it's part of a negative sentiment. So that's why we need to keep the frequency, how frequent, or how many time the word is going to repeat it, right? So fine, but yes, if we want, we can remove, and we can also use this set. It doesn't matter, right? Janik said that, can you explain how this code will remove the punctuation? Okay, so for that purpose, in the string punctuation, you can just see the list, right? So I hope my screen is visible, and if you just see the list, these are some list of punctuation. So if a particular word is any one of them, then it is removed, right? What we have used, we just have used that word is not in this particular list, right? So if it is present, then it is going to be removed, right? And once again, this is the predefined list inside the string, right? So if you want to keep some punctuation, you should customize your list, and you should check with that list rather than considering this predefined list of string. Fine. So now just any doubt in this particular cell? So just keep one thing in mind. This process tweet function, the input of this process tweet will be a single tweet, and the output is it will give you the list of words. And after applying some operation, and that operation are some regular expression, then stemming, as well as the all the stop words are removed, all the punctuation marks are removed, and then later whichever remaining words are there, on that we are applying that porter streamer, and then the result we are keeping, or the result we are returning. Fine. So this is the process to it. Next function is build frequency. So in this function, what we'll do, we'll count for all the words, we'll count how many time a word is labeled as a positive or how many time it is labeled as a negative, right? Where the positive means 1 and the negative means the 0 as per the data set that we are going to consider, right? The data set that we are going to download, in that the positive are classified as 1 or labeled as 1 and the negative are labeled as 0. Right? And then next level, we are going to build a frequency dictionary. Right? We are going to build a dictionary. The dictionary contains word as a key and whatever is a label. Sorry, the key label. Word and the label as a tuple. Right? And the value of that particular key is a count. Once again, I'm repeating the statement. We'll create the dictionary where the key is word plus label and the value is the count, or you can say the frequency of that particular word label. So maximum, okay, can you tell me how many time at max particular word will be there in my dictionary as per this logic? Twice, right? So let's say some XYZ word, if it is present in the positive sentiment, then the word, the positive sentiment and the count. For example, it might be like this. Let's say XYZ 1 value would be, let's say, 10. XYZ 2, let's say the value would be 29. So this 2 entry might be there for a particular word XYZ. Sorry, not 2, 0. Which indicates that XYZ, the word XYZ is present in a positive tweets, or you can say in positive sentiment for 10 times, right? Whichever your training data set over there, or you can say whichever is your data set over there, it is observed 10 times as a positive labeled, while 29 time it is observed as the negative label. So this is a maximum. It can be there maximum twice, right? Not more than that, right? It may be one time also. Let's say if always a particular word, let's say happy, if always that happy word occurs as a positive word, then it will be counted as positive. So that is happy and 1 would be some value, while there is no entry related to happy and 0. But generally this happy is not counted as positive, because if you consider some tweet, the word might be I am not happy. Fine. So the word happy is still present, but the sentiment of that particular tweet is negative. Fine. So this will be the output from this build frequency function, right? We want that the build frequency should generate this output for a given words, right? And we'll supply all the tweets as well as the y values, right? Or you can say as well as the labels. Fine. We are converting that particular label. I hope you are aware about this particular function. So if you want to select a particular values, let's say if you want to select a column from matrix, use such. Fine. Now initially this frequency is empty. What we will do for y list as well as the tweets, will generate y, will have y and the tweet, right? Next, this tweet is a string. First of all, remember, just consider these two things, tweet and tweets. We have two words or two variables. So this tweet is a string. Now for that particular string, we'll call the function process tweet, and the input would be this particular tweet, right? And we know that the process tweet will generate the list of words after applying some operations, right? We have just seen which are that operation. So our key would be the word as well as the y, right? And this operation will repeat for all the words, for all the words of particular tweet. So that is the meaning of this inner loop. I hope you are getting. In outer loop, what we are doing for from my full data set, I am considering one by one tweet as well as what is the label of that tweet. And in an inner loop, for a particular tweet, whichever tweet we have considered, there is only one label. But in a tweet, we have multiple words. Right? So to extract all the important words from the tweet, we have already designed this process tweet function. So inside that inner loop, we are capturing all the words one by one, and we are generating the pairs, and that pair will be word as well as the y. So this will be the key of our dictionary. Right. So now once again your role starts. Now you already have a key. Right. So simply in this frequency, which is initially empty, add this pair if it is not present, and if it is already present, then update the count. That is, one more time we have observed this particular word pair. Let's say the happy comes with the positive sentiment. And so if happy and positive sentiment is already present in your frequency dictionary, then just increase its count by 1. If it is not present at all and you are observing this particular pair for first time, just add it to your dictionary. Clear, Devang, or should I repeat once again? Okay. So basically, what we are doing over here, we have tweets, the full data set, right? This, just focus on this outer loop. Tweet contains full data set. Let's say if you have 1000 tweets, or to be specific, we have 10,000 tweets. So you have 10,000 tweets as well as 10,000 y labels. As you know, it's a supervised learning, so you have the y values, right? So for all 10,000 tweets, you have its according, you have its label. The y would be 10101010, where 1 tends for positive sentiment, 0 tends for negative sentiment. Right? So now from this full list, we are iterating over all the tweets one by one. So we'll consider the first tweet, its label, second tweet, its label, third tweet, its label, and so on. So this variable y as well as tweet contains your single tweet and the label of that single tweet. Fine. So that's the role of outer loop. For all the tweet, we are extracting tweet as well as its label, and we are just iterating through all the tweets. So that is the role of outer loop. Now, whenever we say this tweet variable, what exactly that tweet variable contains? It contains a string, right? Or you can say it's contains tweet, which is ultimately a string. So from the tweet, we are supposed to identify the words, or we are supposed to capture the words, right? And not all the words, but some important words, right? So next level, the next for loop, we have already designed this function process tweet. Right? If you just recall, or if you just see your previous cell, we have already designed this process tweet function. So if you pass a single tweet to that process tweet function, it will capture, or you can say it will give you the list of important words after applying the stemming operation. And so that words, all the words which we are able to retrieve using this process tweet, we are storing into this word. Word is a list, right? Now, sorry, word is a single, at the time it is a single word. So now for particular word and y, where the y is either 1 or 0, right? It's a label which is associated with this particular current tweet. So for word as well as y, we are considering a tuple, and let's say the name of the tuple is pair. And if you can recall the description, what we will do inside this current function, we will generate a dictionary where the key is this particular tuple, word and the y. and the value is frequency count of the tuple, how many time I have observed that entries. So let's say the word, current example is, let's say the word is happy and the y value is 1. So how many times so far before processing the current word, how many time I have observed that tuple, that is happy and y, happy and 1, that will be indicated by your current frequency value. Fine. So let's say if you haven't observed that word so far, so that's the first observation. So we will add that key value to a dictionary. But let's say if you have already observed that word and you have some frequency value, let's say 10. So 10 times you have already observed. So this current observation is 11th observation. So you should increase that count. Fine. So that code you have to write. The next thing is you have to write that you just need to update the count if it is present, and if it is not present, then you should initialize it by 1. Right. So at the end, whenever we call this build frequency, this function will generate frequency for all the words, right? And to be specific, for all the words with its appropriate sentiment. So it might possible that the word is present twice, one with the positive sentiment and some frequency, one with the negative sentiment and some frequency. I hope it's clear now. Fine. So now try this thing and try to complete this pair. Done. So good thing is in this short break, I am just removing that unnecessary, or I'm trying to mute myself whenever there is unnecessary sound due to the train or the railway track, which is very near to my current location, right? So now, the simplest thing is you have to consider all the pairs, the current pair, and you have to check it whether it is present in the frequency or not, whether it's present in the dictionary or not. If it is present in the dictionary, we'll update the count, we'll increment the count by 1. If it is not present and if it is a first observation, so in the else part, we will set the count to 1. Fine. So now we have two functions ready. Build frequency, which will generate a tuple, and the tuple contains word as well as the label, that is whether it's positive or the negative word, along with its frequency. And the other pre-processing task. So now let's focus on the data. So this Twitter sample data that we are going to use contains 5,000 positive and the 5,000 negative tweets, right? So we know this thing. We have actually used the Twitter previously, right? Twitter example previously. So you just need to run the cell, and this all positive tweet will contain positive tweets. This all negative tweets contain the negative examples, right? And in the next cell, you need to split the data into 80-20 ratio, where 80% will give to the training and the remaining 20% will set it to the test data, right? But the split should be from both, from positive, whichever 5,000 positive samples we have, from that we'll consider 80%, plus from negative 5,000 sample we'll consider 80%. So the summation of both will be your training data set. And similarly, remaining 20% from both the entries, that is all positive as well as all negative. So remaining 20% from both will combine together and we'll consider that particular as an test answer. Fine. So just quickly try to fill this value. What should be the test positive? What should be the train positive? Test negative, train negative, and finally train x and the test x, where the train x should indicate the final x value, the combined x value, and the test x indicates the combined x value for testing. Over here, what we are supposed to do, all positive tweets, and from that we need to consider, let's say we are considering the initial entries. So what will be your train x? So initially 4,000 we are moving, or we are keeping into the training, and the remaining 1,000 entries we are keeping into the test set, right? And the same we are repeating for the negative also, positive as well as for the negative. So in the training we'll have 4,000 plus 4,000, that is 8,000 entry, and the testing we have 2,000 fits. So the train x will be, what should I write over here? Oh, okay, let me write it, because otherwise you have to write it in your code as well as you have to write it in the comment also. So it should be train, as it is a train, so train underscore positive plus train underscore negative. Similarly for the testing, test underscore positive plus test underscore negative. Right. And now in the next level, we are creating an numpy array, where for the training, we know that initially we have added the positive and the next values are negative. So first we'll consider numpy array with the 1, where the length, the how many entries will be there depends on the length of train positive. Next we'll add zeros. Once again the length would be the length of negative, and the same will repeat for test set, right? So this, in a previous cell you can say we have designed our x and the x values for training and the testing, and in the current cell we have designed y values for training and testing, and where the y values are just 1 and 0. So complete up to this step, and then maybe after 3 or 5 minutes we'll continue with the remaining discussion. But try to revise the stops, what whichever stops we have implemented or whichever code we have implemented so far. We haven't touched this logistic regression, right? We are supposed to start that model, but before starting the model, these pre-processing tasks are very important, because what I feel that in many cases, what I have observed, that whenever you learn something, let's say when you learn the logistic regression, everybody will tell you that there is a logistic regression, you are supposed to use it like that, and they will give you the data in Excel, right? So you need to process that Excel and you need to generate the answer. But when you approach towards industry, nobody is going to give you that Excel, right? So nobody is going to give you that filtered data. You need to apply that data maybe to the tweets, to the other social networking site, or maybe some other classification or some other regression problems, right? So there are many pre-processing tasks involved before moving or before starting or your original model. So that's why I thought it would be good practice to spend at least 2 laboratory on this logistic regression. And first, we'll have the so in the last we have implemented it from the scratch, but now we are trying it on some real-time application, real-world application, right? Done up to this point. Shall we start the next cell, the discussion of next cell? Have you completed this current cell that is combining the Y set or the generating the Y set? Jaimin, Mayank, yes. Others, Ansuman, yes. Ria, yes. Can I expect 86 or not 86, 84 answer? Because I am logging twice, right? So I can expect 84 answer. So these answers are really, really very interesting, because from this answer, by looking at this answer, I can just conclude one thing, that how many of you are actually practicing, or at least how many of you are actually listening the lecture, and how many other students are just join the meeting and I don't know what the people are doing. And there could be one another interesting observation. Let's say if it is a very late reply, we may observe that there are many helpful people in the group, those using the WhatsApp or some other social media to activate the other students, those who are right now maybe in the inactive mode, or maybe the neurons are right now not active, and they are just learned, or the parameter are just tuned, but the activation layer is not just passed. Okay, so now let's move forward. This was just to give some time to students, those who are not able to complete the previous step. But I hope now everybody else, everybody have completed these steps. So now next is we are going to call this build frequency function. Okay, so tell me what will be the input. Just check the build frequency function and identify what should be the input for this build frequency. Right, so we'll pass the train X as well as the train Y. And if everything is fine, then we'll get the output of that frequency. Right, so that is a dictionary. We have the dictionary, and the length of the dictionary is 11346. And now I hope in your case also you will get the same length. right? Because we all are using the same data. Our train test split is similar. Done. And if you just forgot, then this note is for you. This frequency dictionary, the output, this 11346 is actually that many key value pairs that we have, where each key can be something like this word as well as its sentiment, and the value associated with this particular key, let's say the happy one, and value, let's assume 100. So the meaning is the word happy with the sentiment 1 occurs 100 times, right, in our training set. And similarly, we have entries for all other words which are present, right? So if you want to check, you can randomly check some words. You can print the key values pair, or you can say, if you want, you can print all the values, all the key values pair, right? 11340. Okay, any other answer? 11346. In my case, it's 11346, and Mayank and Milan are getting that 11340. Any other answer? 11169. So have we used shuffle somewhere? Have we shuffled the data? Why different students have a different answer? So many of you are getting that 11346, but in other case we are getting some other answers. So can you guys just check that? Have you shuffled the data somewhere so that training set or the data that we are passing to this build frequency may have some different words than what we are passing? So majority of you are getting that 11346, and what I expect that as our data set is same, we should have the same result, as we are not suffering, because initial those who are getting different answer, just verify that have you passed initial 4000 to training and the remaining 1000 to the testing or something else. Because if it is not the scenario, then the result that you guys are getting are really interesting. We have to identify why you have the different results, right? So are you all have the same input, that is first 4000 to the training and the remaining entries to the test, or something else? Mayank say yes. What about other? Milan, Darshan, Kumar, Vivek? Okay, so 11346. Darshan and Vivek. Maybe RE or steaming or some operation might be missing, so you might have same word multiple time. So what probable reason could be? Your training set should be different, and the reason for the difference can be, let's say you haven't applied the steam operation, so that the same word might be there multiple times, or let's say your training set that you are picking, it might be not the same range that we have considered, or so on, right? But it doesn't matter, fine. You can lateral check the reason, And let's say if some of you may able to find the reason, please post it into the group so the other will observe as well as I will come to know that what exactly the scenario, why we have the different results. Okay, so in the case of Darshan, the change in the steaming as well as the punctuation, fine, so that's fine, right? So if you are, let's say, if you forgot that punctuation step, right, if you don't apply the punctuation, so what happened, that punctuation marks, if it is present in the training data set, it is also considered as a word, right? And related to that word we will have some count. Or let's say if you do not apply the stemming, once again all the different word rather than the root word, all the different uh, all the difference of that particular word might be there. Okay, fine. So now fine, so I guess all of you might get that 11346, and even if you're getting some other values, don't worry, because it won't affect the performance at max level. It affects at some level, but not there will not be a significant change in the performance, right? So don't worry. And the reason, I hope the reason that I have discussed, the one of the reason might be there if you are getting some different answer. So now if we move forward, so this build frequency, we have called the build frequency for the training. For full our trend set, we have this frequency set ready, and we have this 11346 entries in the dictionary that just that we have just compiled. And so now you can just test some examples, right? So one example is given over there. Just test this example. We know that the initial we have appended the positive set, right? So let's say if I just try to print the train x of 0, it is actually the positive example, right? And the process version you can also check by passing at that particular single example, because if you can recall, this process tweet just need a single tweet, right? And similarly you can try for some negative examples also. Let's say if you give the value train x of 4012 or somewhere around higher than if the value is higher than 4000, then you will get all the negative tweets, and accordingly you can check the answer. Fine. So after this pre-processing, let's go back to the model design where we are using this logistic regression. So the first is the sigmoid function. Fine. So we have designed this thing in the previous laboratory. So I expect that you should, even if you don't remember that thing, the equations are over here for you. So I hope you can just put that equation. So let's say we are creating the sigmoid function where if I pass this z, it will calculate the h value. Right, so the calculation of that h value is just the activation, that is 1 upon 1 plus e raised to the z value that we just have. And so just try to write the equation for this h, and over here you can use the numpy. Okay, so Jainik is asking that the last element of the list shouldn't be removed in the process tweet. Are you talking about this highlighted element, Jainik? Okay, so anyone wants to answer this? Why this element is there? It shouldn't be removed. Right, it's not the punctuation mark, it's an emoji, right? It's a combination of punctuation, right? So one interesting thing, good point, Janik. One interesting thing that you should observe is the colon is a punctuation, the opening or the closing bracket both are the punctuation. Right now we have used the colon and the closing bracket, but together that is without any space, if you are writing colon in the punctuation, that's sorry, colon in the closing bracket, that's not the punctuation mark, because it's an emoji representation, right? So we are supposed to keep it, and that's why if you recall that punctuation, just consider colon. If it says just a colon, it is going to be removed. If it is just a closing bracket, it is going to remove, but that is not the, this is not the stop word. And for the Twitter analysis, or you can say the tweet analysis, this is very important aspect, that is we are using the emojis also in the consideration. The current emoji generally represent the positive sentiment. Okay, so now H, write down the equation of H. Actually, my audio was mute. Next, after writing this h of z, the next is, if you can recall this logistic regression, it is basically how we were computing the z. Z was derived from the linear regression, where it's just a combination of parameter, that is theta or the weight value, as well as the features, that is x values. Fine. And on that we are applying the activation, that is a sigmoid activation, and we are able to get this h. Sorry. Right. And if you can recall this updation rules, the gradient descent, right? So we have discussed this gradient descent whenever we discuss the logistic regression, and many of you have written the same thing in the paper also. So I hope it's clear. So now you need to implement this thing, right, as we are implementing this logistic regression from the scratch. Otherwise you can use the versions of logistic regression which are available, and then as a part of exercise you are supposed to do the same thing. In the last laboratory, we have discussed the logistic regression from scratch, as well as we have discussed the same algorithm from, you can say, from the TensorFlow's perspective. And so, as a part of this laboratory, you have to repeat the same exercise, the same process, but instead of this manual version of logistic regression, you need to just update it with the TensorFlow's version. That's it. Right. So now the gradient descent, x, y, theta, alpha, and the number of iteration, we are passing these values to the function, right? And you need to complete the code of this particular function. The equation of z, equation of h, the j equation, it's a bit complex, or you can say a bit lengthy, so I have keep that equation as it is. Otherwise you can also write the same equation by looking at above figures. Fine. And the theta updation, the j updation rule, and we'll at the end we'll return j as well as the theta values. Fine. So quickly complete this code for z as well as the h. For that you can use the sigmoid function that we have just designed. Okay, so I hope you have written this particular code, the multiplication, the sigmoid, and the lateral, the updation of theta, right, where you are supposed to have the x transpose. And then I hope you can recall this at the rate. So please try to complete this if you haven't done it yet. And after this particular cell, our pre-processing is ready. Our model is also ready. So next thing is we just need to consider some features from the data that we have, and we need to train our model, the holistic regression model, onto that particular data, and later we are supposed to test the performance and the usual steps that we were following in many of the previous laboratories. Right, so I guess for the assignment task of the laboratory, this cell, you have to work on this particular cell, the current cell as well as the previous cell where we have used the sigmoid, right? And if you can recall that sigmoid is also available, let's say if you are using the numpy, it is already available in numpy as well as in the TensorFlow it is available. But right now we are using our own version, but you can update that values too. And we know that the gradient calculation that we have done over here is actually not needed if you are using the TensorFlow. On your behalf, the TensorFlow have the support to calculate that gradients. And so that thing you are supposed to explore in the laboratory task. So now let's move forward. So just focus on this particular where you are supposed to extract the features, and our feature, we just have two features. So we have list of tweets. From that list, we'll extract the feature and we'll store that particular feature into matrix, right? And as I've discussed, we have two feature. The one is how many positive words are there in a particular tweet, and the second is how many negative words are there in the tweet. Right? The simplest model that we are designing, where we are just focusing on the count, how many positive words are there. That count we are storing into the one feature set, or you can say one column, and how many negative words are there, that count we are storing into the other column. So that two features, x1 x2, are the two features for our model, and we know the y values we already have. And so I hope from this the training picture is clear. What we will do for all the tweets, if you can just recall without looking at the solution, if you can just recall whichever tweet that we have in the training set. So for all the tweets, one by one, we will build a frequency. Sorry, the frequencies are already ready, right? So all the words which are present over there, it's whether it's positive or negative, we'll verify that. Fine. And the count, how many positive words are there, that will consider as a first feature of my model. And similarly for the negative, right? So for all tweets, we'll repeat this particular exercise. Right? And from that we will generate, you can say, the Excel, right? So in academia, generally that Excel which is given to student whenever you are supposed to learn the logistic regression, right? But to generate that Excel, I guess this kind of exercise, but not only this, there are many ways to generate the feature, right? So we have just considered the simplest version where we just have the two column, where each column, the first column indicate the positive and the second indicates the negative words, the count of that words. Fine. And I hope once you have that Excel, we all are master. Rather than Excel, let me tell you the table. Let me tell it as a table, right? So table or the matrix, once you have that matrix, we all are master to apply this logistic regression algorithm, and we'll able to generate the answer. Fine. So now let's see this next function, extract features, where we are passing the frequency, that is dictionary, as well as a tweet. Right? And remember that we are just passing a single tweet. So we will call this extract features. Whenever we call this particular function, we will call it for all the tweets one by one. Right? So input is tweet as well as the frequency, that is a dictionary. And the output is feature vector of dimension 1 cross 3. Why it's 1 cross 3? Isn't it 1 cross 2? Right, correct. Name is Viral. Actually, we have three features, right? The first is a bias term, x0. X1 will be your positive value and the x2 will be the negative value, right? And as we are going to return the x set only, the y set is already generated, right? We have the 1 0 sequence for the y values, right? We just need to worry about the x set. So for each tweet, we have three entry where the first entry is always set to 1. Well, let's say we are setting the bias to 1. So the first entry, that is x0, is always set to 1, and the remaining second and the third entry indicates the count. Okay. So now try to complete this word list where you need to tokenize the word, you need to apply the stemming, as well as you need to remove the stop word. So what should I write over here? Right, the process tweet, right? We have already designed the function. So let's just use that process tweet. Process tweet and the tweet that we are supposed to pass. And so for that tweet that we have, for that it is going to generate the list, right? The word list. Then we have the numpy array of size 1 cross 3, and we are setting the bias term to 0. And now for the words, for all the words of this word list, we will check whether that word is present in the positive, whether that particular word is present as positive word. Next, we'll check whether it is present as a negative word. If so, accordingly, we'll adjust the count, or accordingly, we'll set the count of x of 01 and x of 02. And so over here, you have to write some code such that you are going to update x of 01. For this, you are supposed to update the x of 01, and over here you are supposed to update x of 02. So try to complete this statement and try to think what should be the code over here. Let me once again stop this sharing and try to complete this code, and I'm also trying to complete the code, right? So think on it. It's a very simple thing. You need to just identify something, whether you need to just identify whether it's present as a positive or not. If it is present, then update the count, otherwise do not update the count, right? So just try to write the code. Done. Okay, so let's see. That's so simply what we are supposed to do. We have to check whether that combination, that is the tuple word and one, where if you can recall, the one means a positive, zero means negative. So whether it is present as a key in the frequency dictionary. If it is, whatever is the frequency count, we will add it to the x of 0, 1. And so whatever is the frequency count, that is whatever is the value of that key, we will add it to this x of 0, 1, where the 0, 1 indicates the frequency of the positive words that we have in the current data set. Right? And same thing we are repeating for a negative word. If it is present in the frequency, if so, then we'll increment the count. Fine, and just test this function on the on some input. Let's say first I'm testing it on the train x0, that is the first bit, and then I'm testing on some other data. Let's say I'm testing it on my name, right? So just try to test this function and specifically observe this train x0, whether you are getting the same output or different, whether you are getting this particular output or not. Right, so these are the features, right? So this one is a bias value. This 3.02 e raised to zero point 0.3 e raised to 0.3 is the positive feature. That is, you can say the count, the positive count, and this indicates the negative, right? From this particular train x underscore 0. So let me just open the code that I have written. I hope you have written it, but if let's say some of you are lagging behind, and if you can't able to complete it, just try this code in your computer, and then lateral just run the remaining two cell, that is test 1 and test 2, just run on that cell and observe the output. Meanwhile, those who have completed the steps, can you tell me what will be the meaning of this 100? Right, so the two words that we are passing, none of them are present in our data set, right? So the frequency count is not going to modify, or it's not going to update it. So let's just try with some other word. Let's say if we try with the word happy. So if you observe, the meaning over here is the word happy is present as a positive in a positive tweet 161 time, and it is also present in the negative tweet 18 time. and so on, right? So you can just try with some different word. Let's say if I just, instead of this, if I write the word said, we can expect that the negative count should be larger compared to the positive, right? So with the positive it just occurs 5 times, and with the negative it occurs 100 times, and so on. You can try different things over here. Yes, good observation, Mayank. If you try, let's say, okay, everyone, please try the words which Mayank has mentioned, happy as well as happy, ended with I and ended with Y. So output will be with respect to the hello, right? Devang, do you have this output 49 and 8? So have you written that end or just these two words? So no matter whether I have written this Pandya or not, the output is same, that is 49 and 8. No, no, that is not for the word. This actually, okay, so let me just make it simple. Let's say I'm just writing hello. Fine. So still I'm getting the same answer, that is 49 and 8. So the meaning over here is this hello word present in the positive tweet 49 times, and it is present in the negative tweet 8 times. Right? Let me just write it somewhere around over here so it will be more clear. Hello, positive 49 times and negative 8 times. Let me write word end. Or let me write said. So the word said present in the positive tweet 5 times and in the negative tweet 100 times. So now if I write hello said, can anyone tell me what would be the answer without executing the code? Right. So now let me just verify that. Fine. So that is 54 and 108. So simply what it has done, 49 for the hello, 5 for the said. So 49 plus 5, so that is 54. Similarly, negative 8 plus 100, so that is 108. Fine. And in your case, let's say if I add the new word, unknown word, let's say the Pandya, or you can add your name also, right? So that words are most probably not present in the tweet. Let's assume that the particular word is not present. But let's say if it is present, then the count will be accordingly changed. But right now, if I add some unknown word, its frequency count is 0, no matter whether it's positive or the negative. So my final output won't change. That is 54 and 108. But if I now write, let's say, hello, said, count is changed. Now I hope we can introduce, or we can perfectly answer the question which was initially raised by Mayank, why we are not removing that word. If it is a repeated word, why we are not removing that repeated word? Who has asked that question? Right. So I hope it's clear. So in a tweet, generally we are interested in number of words. We are not interested in a sequence or whether it's repeated or not. Because generally, let's say my tweet can be, I am sad, very sad. Or why should we become sad? I am happy, very happy. I want this both occurrence of happy so that the positive count will be higher. right? If you want, you can definitely remove one occurrence, or if you want, you can just keep the one. But to give higher weightage to the positive count, it is advisable to keep both the versions. And so that's why we haven't removed that word. But yes, depend on the application, you can definitely remove that if it is repeated. Fine. So shall we move towards the last step, that is training our model? Or any further doubts in this output or any other steps that we have discussed so far? Anyone? Okay. So now, so if you observed in a training, we just need to consider x value and we need to apply the gradient descent. Fine. So we are initializing this capital X, which is initially zeros of size, whatever is the training example, into 3. Where if you can recall, the 3 means the first is a bias, the second one is the positive count or positive frequency count, and the third one would be the negative frequency count. Right? So once again, without executing this cell, can you tell me what will be the exact size of this capital X? Please don't execute the cell and don't print the length. But without doing that, can you tell me what will be the size of this capital X? Right. And so we have 3 features and 8,000 examples, where out of that 8,000, first 4,000 are the positive example and the remaining 4,000 are the negative examples. Right. So this is our training set. So now what we are supposed to do, we have initialized this X with the zeros. So using this particular for loop, we are putting the appropriate frequency values, right? So to extract the frequency values of all the words, we have already designed this function, extract features. And so at every iteration, we are passing the trend value, that is the particular tweet, along with the frequency to this extract feature. And we know that the extract feature will give us a 1x3 value, where the first one is always labeled with the 1, that is a bias term, and the second will be the positive words frequency count summation. Once again, summation of frequency of positive words, right? And the third indicates summation of frequency of negative words. Fine. And simply the y would be the y train. Okay, so we are ready with the model. We'll call this gradient descent for x, y, right? And recall that what will be the third argument? Just open that gradient descent and observe which was the third argument. Theta, right? The other are the alpha as well as number of iteration. Fine. So now where is the code? So we are setting the alpha value as well as we are setting the number of iteration. Set it to some smaller number so that the training will not take much higher time. Right? And the weights we are initializing to 0. I have trained it for 10 iterations only, and the cost after the training would be 0.68. Right? If you want, you can try it for some higher number. You can train it for some higher values. Let me just try it for, let's say, 100 epochs, 100 iterations. Right? Not much significant difference in the performance. So once again, it's 0.6. Okay, so now last step, that is prediction, right? So your model is ready now. Now you need to predict the answer for a test set. So try to generate this x and the y values. So your parameters are ready, right? So the x will be, you are supposed to extract the features. So extract features width that we have given as an input, as well as the frequency we are supposed to pass, right? And we'll call this predict width for all the test examples to measure the performance. Okay, can anyone tell me what would the y predict? What should be the equation of y predict, or which function we should call? Right. So we are going to call the sigmoid on the x value that we just have compiled along with the theta. Right. So x into theta will be your you can say linear regression model, in that we are applying to the activation function, which is nothing but the sigmoid function. Right. And just remember that this theta is now not the 0 or 1. It is now updated values of weight. Fine. So now whichever is my new input, that is whichever is my test input, on the test input I am multiplying the test input with the updated weights, and on the result this x at the theta will be considered, this multiplication, the dot product of x and theta will generate the z. So on that result z we are applying the sigmoid, right? So y predict will accordingly give the answer, right? So what will the range of this y predict? Right. So the y predict will be between 0 to 1. Fine. So now we have some sample over here. So for all sample, just observe the answer. Your answer might be different if your number of iterations are different. But let's say if your iterations are same to mine, then probably you will have the same answers, right? So for all the tweets, just observe the prediction, that is y predict. Now we said that for every tweet in the test, it is giving 0.5. But we haven't applied on the test set yet. I guess you have completed the remaining code. Is it so, Nemis? Okay, so we'll see. Right, so this is the, you can say the probability value, right? As the sigmoid is going to give you the value between 0 to 1, that's some probability values. So you have to pick one threshold. So if the value is, let's say, higher than the threshold, you should say that it's in positive tweet. If it is lesser than the threshold, you should say that negative tweet, and vice versa, right? So now in the last step, that is the testing of our model. So for all the entries of this test X, we'll extract it one by one into this tweet. We'll call this predict tweet with a tweet frequency and the theta, and we'll have some y predict value, right? So if y predict is greater than 0.5, then we will say the label is 1. Otherwise, we'll say the label is 0. And so for all the entries, we'll have a particular label. And next, to measure the performance, you have to just compare this y hat value with the test value, that is test y. And wherever the match found, we'll count that particular value in the calculation of accuracy. If not found, then we'll count it, will not count it, right? So this is just the conversion and the reshaping your test y values. So whenever it's equal, we'll consider how many such equal entries are there, right, and divide it by the total numbers, that is m. So in your case, the final performance is 0.5 Nemish. Predict tweet is not defined. Where is the predict tweet? But in my case, I'm getting that 0.98. What about others? Just try to run the remaining code and observe whether you are getting that 0.5 or 0.98, around 0.98. So Nemis is getting that final answer, the accuracy is 0.5. The reason is what happened in his case, every class or you can say every tweets are going to be classified as 0.5. The answer, the prediction answer is 0.5. So whenever you apply that classification, the threshold is 0.5. So every tweets are classified as 0, 0, 0. That is negative tweet. Right, but in majority of the case, the answer is around 90% or 98%, and sometime higher than that 98 also, right? 98.60. So I guess you might have missed something. Maybe the calculation. This calculation is already given, right? So some other calculation. Found the problem. So can you just share that problem so that the other will learn something from the problem? And I don't know what's the full form of this ONR. Silly one. So no one. I can't able to understand what you wants to if you have the mic, you can just unmute yourself and you can just share your problem definition. Not the problem definition, but the problem that you have observed. Fine. So you have to type, right? So please type it in a comment what exactly the issue was, so that if let's say in future somebody else is getting the same issue, then he may look around such problems, right? Meanwhile, I hope it's clear and there is no doubt in this execution, and everybody, I can expect at least out of the 68 students, initially we have started with the count 86, but right now the current student count is 68. So after this decrease of the count, I don't know what's the reason, but the students, all 68 students, not all 68, but 66 students, those who are present right now, I hope it's clear, and at least this and remember that this is not the end, right? This is this, you can say we are just starting, or we are just beginning with the machine learning field. આપણે ખાલી પાપા પગલી જ કરીએ છીએ. Okay, so the theta value was 0, right? So in the case of the execution which Nemis has done, the theta value was 0. So there was no weight updation, and accordingly the output was there. Fine. So uh, the lab task, you can refer the lab 6 where we have the TensorFlow based version of this logistic regression. So simply you have to consider all the pre-processing and the post-processing as it is. You just need to remove the code of manual calculation of the model, this logistic regression, and you have to apply the TensorFlow based version that we have just discussed, right? So we'll keep the features as it is. And I hope from this example, once again, the full picture is clear how exactly you can approach a given problem. Invalid value. Is it in this log? So probably you can check this z calculation as well as the sigmoid function that we have applied. Whether that, oh yes, one limitation, yes. So it depends on the data, but I guess in this case it should not be there. I don't know why you are getting that issue. So what's the reason, Atish? In the sigmoid calculation, and what exactly the problem was? Okay, that's fine. And but in the last laboratory, if you can recall, we have discussed one point. This logistic regression, you have to handle one specific case. Right now, we do not have that case, but if this is a very rare case, but you have to handle that rare case. Can you recall that? Thanks to this logarithm, and if I give you one hint, logarithm and the infinite value. Yes. So when the logarithm will result in the infinite value, right? So whenever the h is 0, so when the h can be a 0, when the sigmoid will result in 0. It's already open. A gradient descent is already over here, right? Uh, so when the sigmoid can be a sigmoid can generate 0. So if you just try to plot it 1 upon 1 plus e raised to something, right? So what should be that something such that the sigmoid will result in 0? Fine. So whenever you have time, just look at that particular issue, right? In last laboratory, we have discussed it, so I'm not going to repeat it, but just try to identify the situation when it's very rare situation, but when it is possible that this particular j value due to this logarithm, or you can say it generates the infinite, right? And you need to handle that situation also. So we can say this model that we have developed, it's very basic version. There are many loopholes in the model, so we need to remove the loopholes, as well as the features that we have considered are very simplified features, where we are just considering the count of positive and the negative words. But this is very good for the beginners, as we are beginning with this all machine learning models. But lateral, you may think about many other features, you may think about the tokenizing task, as well as many other things, right? So Vivek has identified some. So interesting. At least many or few students are really taking the active participation in the chat, as well as they are developing the code, as well as they are understanding the concept in depth. Okay, so with this, let's conclude this laboratory, and maybe with the next lab, we may discuss either the clustering, or let's say in Bridges sir's portion, if SVM is discussed, then we will discuss the SVM in the laboratory also. But we'll see. At least the clustering portion is definitely going to be cleared before the laboratory. So we'll discuss the clustering in the next lab, and maybe after the next lab, we'll discuss the SVM. Okay. Thanks for attending the laboratory. Have a nice day.